In this lesson, you will learn how to work with geometric figures with polynomials. So let's look at our different geometric figures. We have a rectangle or square. In order to find the perimeter, you do the sum of all the sides. And recall that rectangles and squares have 4 sides. When you're finding the perimeter, you should be adding up, finding the sum of all 4 sides. Don't leave any out or find any extra, just the 4 sides. There is a formula for perimeter when working with rectangles and squares. The perimeter is 2 times the length plus 2 times the width. So instead of adding up all the sides, you can take 2 of the lengths and add it with 2 of the widths, and it still will result in the same perimeter. For area of a rectangle and square, you can use length times width. So if you'll recall, a square actually has all 4 sides equaling the same thing, so you actually wouldn't have a different measurement for length and width. So there is a formula that you can just do sides squared. However, I prefer just sticking with length and width no matter if it's a rectangle or square. Even though your length and width will be the same, it will still find the area of that square. For a triangle, again, you can do the sum of all the sides to find the perimeter. And recall that a triangle has 3 sides. So when you're finding the sum of all the sides, you should only be adding up the 3 sides of the triangle. Be careful to not include the height unless the height is actually the side of the triangle. You should only be including 3 parts, those sides of the triangle. There is no formula for calculating perimeter of a triangle. You really just need to add up all the sides. For area of a triangle, it is 1/2 base times height. So let's go back to a rectangle. If you imagine a rectangle, here we have maybe the length and the width. That's how we calculate the area. Well, if we cut that rectangle in half, and now instead of calling it length and width, if we call it base and height, this area of the triangle is 1/2 the base and height, or it still can be called length and width because that's what we call it when it's a rectangle. But that's where the 1/2 comes from, is because you're taking a rectangle, you're cutting it in half, and we just rename the dimensions. Instead of length and width, we call them base and height for a triangle. For a circle, we can't really calculate the perimeter adding up all the sides because the circle is round. So instead of calling it perimeter, it's actually called circumference. So the circumference of a circle, the formula is 2 pi r. We won't be calculating circumference in this lesson, but we will later throughout the semester need to calculate circumference, so it's good to already review that formula. For the area of a circle, you'll do pi r squared. So let's look at some examples for this word. Here we're going to find the perimeter of this rectangle and the area. So when we're finding the perimeter, I prefer to use the formula. You can definitely add up all the sides. You need to add up all 4 sides. But like I said, I prefer the formula. So perimeter equals 2 times the length plus 2 times the width. So 2 times, I let the long side be my length. It really does not matter when you're calculating with a rectangle which one you call length and width, but I prefer letting the long side be length. So x squared plus 5 plus 2 times your width, so we got 2x squared minus 6x. In this case, the parentheses are important because you want to multiply the 2 times the entire length and 2 times the entire width, and not just the first term of the length or width. So 2 times the whole thing, show in parentheses. Same here, 2 times the whole thing, show in parentheses around those length and width. So let's simplify this. 2 times x squared, 2 times 5, 2 times 2x squared, and 2 times negative 6x. So here we have our terms when we distribute those 2's. Now we're going to need to simplify just by combining like terms. We have a 2x squared and a 4x squared. That becomes 6x squared, not to the 4th, but to the squared. 2 plus 4 is 6. X squared and x squared is still an x squared term when you're combining those like terms. Here I have only one x term, so I'm just going to bring it down, as well as the 10. I have nothing to combine it with. So that is the perimeter of this rectangle. Be sure to include your units. Here we're in the dimensions of feet. And if you're measuring the perimeter, the outside edge of this rectangle, you would just measure it in units of feet. So now let's find the area. So area of this figure is going to be length times width. So again, letting the long side be my length, the other side being my width. Again, it really doesn't matter. So we have x squared plus 5. We're going to multiply with the 2x squared minus 6x. So now we're going to use the distributive property. We're going to multiply this x squared times the entire second parentheses. So let's write that out. The 2x squared minus 6x. Then we're going to multiply the 5 again times that entire parentheses. 2x squared minus 6x. So distribute that to each term. So we have x squared times 2x squared. That gives us 2x to the 4th. This is where we add the exponents. When you're multiplying powers, you add those exponents. So x squared times the negative 6x gives us negative 6x to the 3rd. Again, adding those exponents, there's really one there. So x to the 1st and x squared makes 3. Continue distributing. We've got 5 times 2x squared gives us 10x squared, and 5 times negative 6x gives us negative 30x. Let's go ahead and combine like terms. So actually we don't have any. This would be our final answer. We have an x to the 4th, x to the 3rd, x squared, and x. They're already in the correct order, descending order by their exponents, so this would be our answer for our area. Go back and get your units. We're in feet, and when you're talking about area, we're in squared units, so squared feet. If you were going to like Lowe's or Home Depot or somewhere to buy flooring, you would order a square footage or square yardage of tile that you need, or whatever kind of surface that you're needing to cover an area of a room. So square footage here. Let's look now at a triangle. So again, doing perimeter, we're going to do the sum of all the sides. Notice this case we're given an extra value. We don't need that value when doing perimeter. So sum of all sides. And let's do that for our perimeter. So we have 7x plus 6. We're going to add that with 10x plus 4. And we're going to add that with 4x minus 4. We did not include this value here that's 5x. That's not a side of the triangle. So now we just need to combine like terms. We've got a 7x, a 10x, and a 4x. So 7 plus 10 is 17, plus 4 more, 17, 18, 19, 20, 21x. Not x squared. We're not multiplying here. We are just combining like terms, so our answer should be that like term. 7x plus 10x plus 4x gives us 21x, not x squared or x cubed or anything else here. It's an x term. Let's combine our constants. We have a 6 plus 4, but then take away 4. So if you'll notice, a positive 4 and a negative 4 actually will cancel one another out, leaving us just with the 6. So here we are calculating our perimeter. So go back and get your units. We are in meters. So perimeter is just in plain old units for meters. If you measure the outside of this triangle, you would just call it in the units of meters. So let's calculate the area. So area equals 1/2 base times height. So in this case, the base of the triangle and the height of the triangle should always meet at this 90-degree angle. When you're identifying a base and height for a triangle, always look for that 90 degrees. So our base I'm going to call the bottom, this 10x plus 4, and the height I'm going to call how high it is, how tall it is, so the 5x. So we have 10x plus 4, we're going to multiply that with the 5x. Always be careful when identifying base and height. You will not want these slanted sides. If you were to stand up and see how tall you were, you'd stand up nice and straight on flat level ground. That's why we're looking for that 90-degree angle for our base and height. You would not lean over crooked ways to find your height. So find that nice 90-degree angle for base and height. At this point, it doesn't really matter how you multiply. You can do the 1/2 times the 10x plus 4. You could go ahead and do the 5x times the 10x plus 4, kind of whatever order you want to multiply. I'm going to stick with the 1/2 times the 10x plus 4 because those are both even, and I can take half of both of those numbers, so it kind of does away with this fraction. So half of 10 is 5, and don't forget your x. Half of 4 is 2. That still needs to be in parentheses because we're still needing to multiply it with this 5x. If it bothers you that the 5x is at the end, flip it around. If you need to write it as 5x times 5x plus 2, flip the order of that so you can distribute. So either of those would be fine. But I'm going to stick with this one. 5x times 5x is 25x squared. Remember, x times x is x squared. Add those exponents. 5x times 2 gives us 10x. And that is our final answer because we cannot combine like terms and go any further. So we have 25x squared plus 10x as our area. Go back and get your units. We're in meters. So we'd call this square meters. So you could put the exponent squared like we did with the feet, or just do SQ for square meters. Either way is acceptable for your units when working with area. So let's look at our last one. We're only going to find the area of circles. You could calculate circumference, but it's just extra practice of multiplication. So we're going to just stick with the area for now. So area of a circle, remember the formula is pi r squared. The radius of a circle is what that r stands for, must go from the center to an edge of the circle. If it goes all the way across, that's called diameter. So we need the radius from the center to the edge of the circle. So area equals pi. Plug in that radius, 3x minus 5, and we're going to square it. So again, being careful that you include your radius in parentheses, because if not, it's going to look like you're just wanting to square the -5, and that's not the case. You want to square the entire radius. So if you'll recall from previous lessons when we worked with exponent properties, we said that a plus b, if all of that is raised to a power, it does not equal a to that power and b to that power. We cannot apply the exponent property when there's a plus or minus sign. It did work with multiplication, so if you have ab to the m, it does work where each thing can be given the exponent, and it also works with division, but it does not work with addition or subtraction. So we've got to decide what can we do with this. We don't have either one of these cases, multiplication or division. We've got to decide how can we simplify when there's a plus or minus. So let's go back here and think. If I've got this whole binomial squared, what does squaring mean? So let's just talk about what does m squared, what does that actually mean? Well, m squared means m times m. So it's repeated multiplication. It tells me how many times we're multiplying that thing together. So that's exactly what we're going to do with this binomial. Of course, the pi, we just kind of stick him in the front for now. The 3x minus 5, we take and write it out twice. That's what squaring means. So 3x minus 5 quantity squared, that whole thing squared means 3x minus 5 times 3x minus 5. And then in this case, we can just use the distributive property as we've previously learned. So we've got the 3x from this first parentheses, we're going to distribute to the 3x minus 5 in the second parentheses. And actually this Parentheses and parentheses is kind of confusing, so let's just turn this to a bracket to say, hey, this pi's out front, everything in the bracket's what I'm kind of working on. So the 3x times the 3x minus 5, and now the minus 5, again, times the 3x minus 5. So close that bracket, and we're just working here on the inside. So we have the pi that we're going to bring down. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. So we've done that distributing. We have negative 5 times 3x is negative 15x. And negative 5 times negative 5 is positive 25. Always watch your sign. Negative times negative is a positive. We can combine like terms here. So negative 15x and negative 15x. And grab another sheet to work on here. So here we're going to just again bring down the pi, or rather yet we can actually just stick the pi at the end if we want to write 9x squared minus 30x plus 25. It is acceptable just to move that pi to the end if it's bothering you at the beginning. Our units are in yards. Remember, we found the area, so it's square yards. This would be an acceptable answer. We often see something like this, like on an ACT type question, if they say find the area in terms of pi, so you would just leave that. We're going to go ahead and distribute pi all the way through so that we can completely simplify. So 9 pi, multiplying that through, and then of course our x squared. Because pi is really a number, it makes sense to put it in front of the variable of the x squared. Then of course we're going to have minus 30 times pi, so again just 30 pi times x, and then the 25 pi. And then we've already said our units are square yards. So really either answer is acceptable. Like I said, we usually see the first one as an option on most standardized tests, but it's also helpful sometimes to distribute that pi through to see what that would look like.